because I think most are black. Let's continue with the black. Okay, so basically there are only a few Docker commands that you actually need to use. Basically, it's the Docker up, right? Docker compose up. For different labs, we will have different YAML files, right? The YML file. So the first lab and the second lab actually basically use the same YAML file. So like tomorrow morning, right? We'll continue. Tomorrow actually have more things to do tomorrow morning. If you can, you possibly want to read through your lab guide first, right? The lab user. Then subsequently, right, every lab they will have their own sort of like the lab setups. The YAML file may be different. Sometimes they may actually share certain files to you, right? Easier to work on things. Okay. Like example, if you look at like the okay, some of these I haven't posted yet. I think I'll post it as soon as possible. Right, the lab 4 to lab 8. Like there are certain parts that we have more machines, which I think is actually more interesting. So we have like the exact reaction have more machines, but you don't have this yet. And we look at the firewall. So you have more machines when you go to firewall. So it's the Docker, the YAML file is good because we don't have to set up all this. You just run the Docker compose up. This whole network is actually up for you to use. Okay. So the other command which is very important is the Docker PS. Because we need to find out what is the container ID. And the next command that is very important is the Docker exec-id. We need to go into the specific Docker machines. So like just now, I actually run the Docker compose up to bring out the whole network. Some of you may see things like pulling down from the internet and things like that. Okay. Then I run the Docker PS. I basically, for today, I should have 3 machines running. Right, tomorrow is the same thing also. I can actually use like the same lab set of files. Right? If you want to be more specific, you can run just command. Just see the ID and the name. Then, this is a very important command, right? I Docker exec to a particular machine, which is the 105. So this is the 105. So when you open up tomorrow, I will open up all the tabs. So what I'll do is open up, right click, new tab. Then I just copy this command. Then I remember that the 1090570. Okay, remember every time you run the Docker compose up, the ID will be different. Yours and your friend will be different. Yours will be different from mine also, 570. I just want to confirm that the machine is correct, so I check its IP address. It should be the .5. Okay. N905. So I run this ifconfig command. It should be one word. Then I grab the particular line that have an inet. So you will not come up everything, like just show me the IP address. Basically, you just ignore the loop back. That's the loop back, which is yourself. So then there's another one, which is the .6 is 20. So it's 20. So again, I right click, new text. Okay, so I go to 20 machine. So I have three containers, right? One flag is one container, this is one container, right? This is the 105. This is the 5. This one is the 6. So usually I work in this way. Well, of course, if you like to have like a new Windows, it's your choice, but I think that is cleaner for me to change, right? To swap from one Docker machine to another's Docker's containers. So this is the network that we have, which is actually here. This one, all right, we have the 105, we have the .5 and the .6. Okay. Then we move on to part 5, right? Packet sniffers and tools. This one I let you read. I let you read yourself. But basically the things is you will have a packet capture, right, for sniffer. You will actually have a packet capture, the PCAP file. You will have a packet analyzer to tell us what is what. Alright, it's actually at this is a TCP IP layers. You have the physical layers, you have the link layers, you have a network layer, then you have a transport layer, and on top is the application layer. So the packet analyzer is at the application layer. Alright, this is the application layer. Okay. So we are going to look at two tools. I just assume that you never use Wireshark, which I think there are quite a number of you are quite well versed in Wireshark, but you may have a few that didn't touch Wireshark before, so we're going to run it as a class. So this is Wireshark is the packet sniffer. Alright, I'll let you read the concept yourself. Alright, this one is the Wireshark, so it's one kind of one type of network sniffer or packet analyzer. So Wireshark, it actually have this interface. You have a display filter, right, this part. You actually have a tools bar on top. You have a packet list. You have the header. We will work a lot in here, the packet listings and the packet header details. Occasionally, we may look at this, like the packet content, the raw file. So each line of this is actually one packet. So we can actually try to start, alright, the host A. So in host A, we ping host B. Right, host A ping host B. What I do? So this is my host, sorry, this is my host A. Just C1 is just send one packet. So this is the ping command. One packet transmitted, one received. I should have this. Then what I'm going to do is I'll open up this Wireshark. Remember the Wireshark is running on your Ubuntu VM. It's not a container. So the lab guide actually asks you to run this button. You choose the any. Any is a little bit difficult to see. I show you the result first. I run any. So this is any. Let me show you again. When you open up your Wireshark, you have this interface. You need to start capturing. Alright, first you see this capture. You click on any. Later I'm going to change it. Alright. So I go to double click this. You start capturing. Alright. There's nothing yet. There's nothing yet. Right? I didn't send anything. So I go back to my terminal. I go to restart the command. Alright, so if you're not familiar with Ubuntu, alright, on Linux, usually you use the up and down arrow key to toggle the command. So this is the command that I previously covered. I use the up arrow key. Hit enter. You send one packet. Go back to here. You see that you have an echo request. Right, echo reply. Because any is a little bit difficult to see and you can't see your sort of like your destination. You only see your source, right? You only see your source. So instead of any, right, you send 4 packets, some will get confused. My suggestion is to turn this off, right? Turn this off in stop capturing, right? Stop capturing. Go to capture, options, see the VR something. The VR something is actually a Docker container, right? See the VR something. Click on the VR something, click start. Go back to here, up arrow key, send 1 packet. Come back to here, this is very easy to see. Alright, don't look at the ARP first. Tomorrow we're going to look at the ARP. I can filter by ICMP. One of the most famous, right, the most popular tool, right, for the in the ICMP family is the ping. So it's the echo request and echo reply. So you see, basically, I ping from 10905. Can you see 10905 here? I ping to 10906. Maybe a little small. Let me just try to zoom in. You can see. Right, can see. This is the packet number by the Wireshark. Right, packet number for the Wireshark. This is the time. Right, stretch over, I'll be able to see. This is the source IP address, destination IP address, protocol that is used. Because I filter by ICMP, you see the green here. There's the echo ping request, and it reply back with ping reply. So you send a ping request, the destination computer sends back a ping reply. Sorry, let me just change that. Right. You send a ping request, the destination computer sends back a ping reply. Basically, this is just to see whether the destination computer is alive or not for ping. Okay. You come here and see this is basically your physical layer. Yeah, look at this this diagram. This diagram. This is actually a physical layer. Then the internet, you can expand and make it small and actually hide it. This is the internet layer or link layer. This is your source MAC address. Right, the 6 computer, actually the front part is the same, you just change the last part. So the source, right, for the packet, the source is 05, the destination is 06. I just read the last part here, 0506. Then this one is the internet protocol, which is actually this, the network layer, right, the network layer. It's like inverted, it's like inverted. This is the internet protocol, the network layer, source .5 or destination.6. Then it's actually on the ICMP protocol. If you expand out, you see that this is the echo request. Right, 8 is the echo request. The reply is the 0, is the echo reply. If you look at like the Linux, this container is actually for OpenTruth. The data that is sent, right, if you click on the expand out the ICMP, but it's more for knowledge. You see the data, you click on here, you see the raw packet, right, it has some special characters and 0, 1, 2, 3, 4, 5. If you capture Windows, if a Windows machine sends a data, it actually sends the data as A, B, C, D, E, F, right, instead of this special characters and 0, 1, 2, 3, 4. It's slightly different. The data is slightly different. So therefore, the end computers, if they analyze your ping, they can determine you are running on a Linux machines or Windows machines. Okay, so I'm actually at the left side. benefit here. But instead of running any interface, right, I capture the PR, which is easier to see because it's just a Docker file. So host A, I ping to host B. So I'm doing the task 5.1, right? Task 5.1. So if you do it successfully, you should see something like this. In request, in reply, you send a ping, right, from your N905. This is what you see in the Wireshark. Can get it, let me just stop. Right, notice one is running more than half here, so you have okay, around 20 plus not here. Hopefully your friends are okay that you can actually set up themselves. Okay, so if you know that they cannot come for the next loop campaign, or if it needs help. So one of the things to highlight is this Wireshark, if you run it in your this virtual machine, the Ubuntu virtual machine, basically can actually capture all the traffic, right, in your container. But later on, when we actually run the TCP down, right, it's just check whatever traffic that is going in or out of that particular container. So we have actually looked at the step 4, find the ICMP, filter by ICMP. Look at the records and find host A and B source MAC addresses respectively. This one we haven't done yet. Alright, so use the IR config command instructions to find a MAC address in host A and B respectively. Check if they are the same. So I'm going to do this faster. So from what I have captured, I can actually show you again. I just stop this. I turn off the filter, this is filter. I go to capture again, options, look at the one that started with BR something, right? The BR something for the Docker network. Click start. Okay, don't have anything like that. Come back to the container again. This is the container. This is the container that is having the IP address of .5. I will send a ping packet. SC1 means that I just send one packet to .6, right? To .6. Hit enter. I get a response. One packet transmitted, one reset, 0 packet lost. Alright. Go back to the Wireshark. See the ICMP. Alright, ignore the ARP, see the ICMP. Or you can filter by ICMP, hit enter. It only show your ICMP packet. Look at this part, the Ethernet. You can expand it or you can look at it here. The source is 02420A090005. This one. Go back to the terminal. Run INET config. The MAC address, okay, there's some jargons. Here actually says find the MAC address, right? Find the MAC address. So this is actually the MAC address, alright? The source is the MAC address. The last byte is 05. Come to here. The last byte is 05, right? 0242, this is correct. So this is called ether. Alright, jargon. Somehow we call it MAC address, or you can call it Ethernet address because it's running in an Ethernet protocol. Some people call it the hardware address. So it's all referred to the MAC address. Alright. So it's correct. This is correct. Then if I go to my next terminal, I run INET config. Look at a 10906. Below it, there's an ether. This is the MAC address. So 0242 last byte is 06. Compared to Wireshark, the destination address, alright, is here. 06. Alright, 0242, then the last byte is 06. So it's correct. Okay. We are going to look at MAC address poisoning tomorrow. So you look at the MAC address. You should know this so that tomorrow will be easier. Okay, so the step 4 is done. Alright, step 4 is done. Most of the time, we will be using Wireshark instead of TCP jump because Wireshark has the UI, and we can actually run it in the Ubuntu machine, so we don't have to run it in the Docker container. But occasionally, we may be using TCP jump. So TCP jump is an alternative tool of Wireshark, but because there's no GUI, it's not that easy to see as compared to Wireshark. Wireshark easier to see the results. It's all here. So we will do the same things, right? We will do the same thing, but now with the TCP jump. Alright, for task 5.2. This is actually the last task for lab 1. Yeah, we may still have some time, so you just go to run this Python skitty. Alright, just do a quick one on Python, so you can actually see what happens. Before tomorrow, you look at the various tasks. So I'm going to move on to task 5.2, capture packets using TCP dumps in a container. I've already done that, right? In the VM, open a terminal, execute the bash and hostly. Basically, you just use the docker exec exec-it command. In hostly, use TCP dump tool to capture all packets through the ETH0 interface. So you run this TCP dump-i, the interface is ETH0-n. So you don't want to resolve the name, copy this, go to my terminal. This is the 10906 container here, TCP dump. What does it tell us to do? Or it tells us to ping, or ping again, ping from host A to host B. Again, go back to host A, ping again. In the meantime, I can actually open up the Wireshark. I think I haven't stopped yet, so it's still capturing. So I already have one queue, so later I should have another two, one echo request, one echo request. So you have to send another packet. Send over. Look at the TCP dump. Alright, this is what I've actually get. Okay, let's see. So this one means that the direction 10905 send to 10906. You look at this arrow key, it is the direction. IP address 10905 send to 10906. This is the protocol being used. ICMP echo request. Then another packet. IP 10906 reply back to 10905. ICMP echo reply. These two packets. Ignore the ARP, or again ignore the ARP, just do it. You can map it with a Wireshark. Go back to Wireshark. You see I have the packet 7 and 8, this is new one. Another ICMP echo request and another reply. See this one? If I send again, I will have another two here. Ping again. You see this one? Alright, okay. Echo request, echo reply. Another one. So my suggestion is don't do a continuous ping. Right? If you just ping without any option in Linux machine is the continuous ping. Windows, they just send out like 4 packets, and then you stop us. But Linux, you need to Control C to stop it if you don't give any options. Alright, again, I'll stop for a while.
What? CDC à? Có. Ủa. Ủa. Tức là UFO nó với cái đó.
Okay, every time you set a ping, you will have a ICMP echo request and ICMP echo reply. For example, you ping in, you see there's two more coming up. This one. Right, note that I actually use the DESC1 to just ping one packet. I didn't do a continuous ping. If you never use any options, right, you just ping the IP address, right? When you go to the TCP down, this is actually what you see. Right? You see a series of ICMP echo requests and replies. This is the TCP down. If I go to my Wireshark, alright, again I'll see a series of ICMP echo requests and replies because I filter by ICMP, so I didn't see the ARP packet. So keep having ping request and reply. Every one row is one packet. So Control C to stop this. Right, so we have completed that one. Right, so this is the part that we have done. So there's a note here, right? The Wireshark captured all packets of our entire network. The virtual machines, Ubuntu virtual machine. The VM here refer to your seed machine, right? The Ubuntu virtual machine. Then you have a host A container, host B container, and host M container. But the TCP dump only capture the packets to and fro or in and out from host B. Okay. Alright, what do I mean, sir? It means in here, right, let me just run the TCP dump in host B. If I go to ping from the 105, alright, to host A, I ping 105 to host A. My TCP dump will not capture the ICMP packet, alright? But my Wireshark, I scroll down to show you. My Wireshark will actually capture this. You see this is the 105 ping 05. Right, 105 ping 05, 05 reply to 105. But my host B, when you actually run TCP dump, you will not capture it. Because the ICMP packet is not for host B. I show you again. Maybe I show a continuous ping. I remove the dash C. This is a continuous ping. I go to my Wireshark. You see that this is progressing by 105 ping to 05. Okay, continuous ping. But when I actually go to the host B TCP dump, you will not see the ICMP packet. Alright, so this TCP dump is only for itself, that particular machine, the container machine. So this is what it means. So we still have half an hour. Alright, you can do a little bit more than your lab. Please, that be my suggestion is you possibly want to, if you don't need to start trying, but you possibly want to read through first. Right, you want to read through. So tomorrow we have more tasks to do. Basically, the container cell, you can actually ignore the container cell task because it's the same as the lab one. Okay. The task actually started from here, alright, your task one, ARP cash poisoning. So my suggestion is you try the Python command, copy this one. There's actually a skeleton code, right? There's a skeleton code. You can actually copy this one. Okay, I want another tab, so I open now. New tab. I can move the tab here. So this is a seed machine, right? The seed machine. Okay, what do I call this? I run gedit commands like just call it net1.py. Consider this as net1. Just right click paste this. This is the code that I actually copied from the lab2 file. Right? Lab2 there's one part in the 3 pass 1 ARP cache poisoning. You're not going to do poisoning today. Just running the skeleton code. This one, copy. Paste it in gedit. The gedit is the UI, so it's easier to use. Now, a little bit about this code. What this code actually means is you import the Scapy's library. So you are going to use Scapy. So Scapy can allow you to modify network. This is the ether. Ether is your link layer. This is like an ARP, alright, the protocol ARP. A.op1 means that this is actually for ARP request. 1 for ARP request, 2 for ARP reply. E/A means that we are going to have this packet using this ether and the ARP. And we are going, send P means that we are going to send this packet. We are going to send this packet. Well, we should actually add something inside the ether and the ARP later on. Save it. Right, save it.
Never record. Only Vegeta.
When you go to your app, right, just you see the lab one. Lab one and lab two, basically the network is the same. You see the host n. The host n actually has something that is called volume. You look at the setup file, the lab setup file, the YAML file. Here, the host n actually have a volume. This one means that the network, alright, the Ubuntu network volumes is going to map to the volume folder in the container. So whatever things that in the seed machine, in this machine, if I copy to the volume, I will be able to see, alright, I will be able to see in the volume, alright, in the container, the host n. So what I'm going to do is copy this left one. Just Ctrl C, place it inside the volume. The left one is inside the volume. And when I have that, when I go to this is the host M. Okay, is this the host? No, sorry, no, just not a host. Let me check. Yeah, this is the host M. But sometimes after a while, you're a little bit confused with just a few machines. This is the host M. So default is the root folder. You see, you also have a volume. You also have volume. When I cd the volume, you see a net1.py is there. Right, so that is like a shared folder that you have set up between your Windows or Mac machines with Ubuntu. So this volume here, alright, this one is the same as you have a volumes in your Ubuntu VM with your container, this container, right, the host name. Whatever things I put in the volumes in the Ubuntu, the volume, it will be in the hostname volume. Alright. So you either do this or you can actually run the Docker copy command. Right? If you don't want to use the volume, then you can use the Docker cp command to copy whatever files to whichever container. So this is the container ID. This is that container's folder. Okay. So there are two ways of sharing them. Usually what happens for the attacker, I will always just use the volume because it's faster. I stop this. I go to capture. Options, right? Choose the PR again, start. This is how you run the Python file. Right? Run Python 3 that one. Actually run this in the host M. Come to here, or actually have this. Because I never add in anything, so I see ARP packet, right? Address resolution packet. So if you run it again, come to here, right, you actually see the ARP packet, which I'm not going to discuss like what is the ARP tomorrow that I'll discuss, but at least you know that this file can be run, but it's not complete as the task that what you want to see there. We can actually run it. Okay. This led to the if you just run Python 3, you'll go into a Python prompt. So you run a Python prompt. Then you can, like, from cp dot or import start. Then you can list the ether. So we haven't added in the source and destination MAC address yet. Right? We didn't actually add in the source and destination MAC address. So tomorrow we need to add in this one. Alright, so but from here we know that it's actually called DST. Source is actually called as MAC address. We can list the ARP. So tomorrow we are going to add in the hardware as SRC. This is the MAC address. This is the hardware destination, so MAC address. This is the IP address, source IP. This is the destination IP. Okay. So So I'm actually just running a quick run for tomorrow this part. But it's actually not a task, but just to show that you can actually work on this using the Python. Alright. So I'm going to stop here. I'm going to stop here. I'm not going to move on. Alright. So my suggestion is you go back, you read through the ARP cache poisoning attack lecture. Then tomorrow we are going to run this lecture, which is the lab which is actually the task is basically using Python. Okay. So first, we look at ARP cache poisoning. We got to create a program, right? You got to create a program to run the poisoning, right? Address resolution protocol poisoning. Then we look at different testing, right? We look at different scenarios, different testing. Alright. Basically, you just see that the cache MAC address is actually changed. Then after that, we do man-in-the-middle attack using telnets. This one is a little bit more structured. So we will first launch the ARP cache poisoning attack to change the ARP cache. And after that, we will sort of like turn on the IP forwarding first, then we turn off again. Then we got to launch the man-in-the-middle attack. And after that, we got to edit this code, alright, edit this code to do a skeleton sniff and spoof program. Okay. You go ahead and read some code to change something. Let me see what is the task. Okay, so whatever traffic that you send, it will be replaced with whatever command is happening, it will replace it. So this is the telnet task. So then the last task for tomorrow, we will do man-in-the-middle attack using the man command. So if you run this two, it's basically like chat. It's like chat. So what you do is you will replace every occurrence of your first name with a sequence of 8. Okay? So in this we are going to modify. We are going to modify. Alright. So tomorrow we have a few tasks to do, but I think it's pretty interesting. So you go back, you read through the lab guide first so that tomorrow we'll be able to start this part and we can actually complete all the activities. Okay. So I'm going to stop here. If you have questions, let me know.
You're buying this? I looked through. He gave one smaller condition, like smaller description. Then he give you like 15 of yeah. You have copy paste. Yes. What? Yeah. He mentioned that some also.
You want to ask about So this is one 7-1. Other class. Just decide.
Crypto on already, is it?
Let's start playing.
Yesterday night we sent out the session.